Hey, good morning, guys. My name is Lance Stedman. I'm one of our PowerFlex specialists here at Dell Technologies.
Hey, I'm Dale. I'm Brendan's stepbrother.
Well, it's nice to meet you both. As you know, we met with your team last week and we walked through a lot of the current issues that you have today, and we pulled a lot of information and we went back to the table. And what I want to talk about today is a possible solution that I think you'll find pretty amazing in how that it can encompass the entire data center and fix a lot of the issues that you've had. So the first thing I want to do is I want to walk through the agenda of what I want to go through today. First, we're going to talk about the issues that we heard from your team, problems that exist today that they're really trying to get over the hump to be more proactive as opposed to reactive in this environment. We're going to walk through some of the requirements that we were able to pull with the help of your team. And then I want to do an overview of a product called PowerFlex. Your team is made well aware of it today. We're going to walk through a little bit today. We're going to go over the overview of it, the architecture. We're going to talk about some automation that's built into it as well. And then I want to show you, I'm excited to show you a production proposed solution that we have that also leaks into a DR solution. Very, very unique in how we've brought it together based on new technologies integrated with the cloud and hyperscalers. And then lastly, I'll open it up for some closing notes and a little bit of Q&A. So just to let you know that we've done our homework, we have investigated your company profile just to understand it a little bit better to help with our solution. We know that you were founded in LA in 2008. Brendan and Dale, you two are the co-owners. We don't know a lot about your fiscal standing today, so we had to take some guesses. But we do know you're always looking for investors. You're always trying to grow. And you probably have one of the most diverse portfolios we've ever seen. So with that being said, we sat down with your team and we asked them to fill out sticky notes and put them on the board, basically outlining issues that they have today. And you'll notice they're pretty diverse, the issues, but they're not uncommon. We see this a lot with a lot of our customers. Things like overworked, things like we don't want forklift upgrades, issues like we're trying to work smarter, not harder. But these are issues that seem unattainable until you actually look at a lot of the solutions that are in the marketplace today. So when we completed this exercise, we went and compiled all of this information, and what we heard was we have too many element managers. We're inefficient because we have too many different technologies in our data center. We don't have a real DR or business continuity solution. We need a consolidated platform for your diverse workloads. We need an easier way to upgrade. We hear that quite a bit from a lot of our customers. Database licensing is out of control. We hear that all the time. Again, we don't like to see these forklift upgrades. We want to do just-in-time growth as needed, whether it be compute or storage or whatnot. And we still have some assets that are under maintenance that if there's any possible way that we can utilize them today, that'd be perfect. And then lastly, we don't really have the ability to be proactive. Like I mentioned, we don't architect solutions. We don't have business analysts that can work with the business themselves. And we sure as I don't have an option for the cloud. We don't have any direction in that regards as well, nor do we have any plans to move to the cloud today. And again, let me reiterate, we hear these all the time. These are very, very common issues. So moving into the requirements, your data center, again, as I mentioned, is very diverse. A lot of different storage platforms, a lot of compute platforms. It must be very difficult to manage. We were told there's 8 FTEs required to administer the entire environment. Upgrades are too complicated. Again, some assets still have maintenance left, and we do have a solution to utilize those as well. And everything is too complicated to upgrade, which obviously it is. You're talking about many, many, many different vendors here. So boiling all this down using live optics and RV tools, we were able to break out each one of the clusters and find some hotspots. So on your Nutanix cluster, for instance, you're running at 81% utilization. That's not uncommon based on Nutanix use of a CVM, right? 31% out of the gate. Resources are being utilized just to cover that. Your Oracle cluster, probably over provisioned, probably because it's running on Exadata today. Just a few areas, your remote clusters are running at 4%. Why not consolidate? As we talked to the team, we realized the pipes would handle it. So we're going to talk about consolidating all of these clusters into one, and that's what this totals is. You're running about a 70-30 read-write ratio, 32 K block sizes. Your max IOPS are right over 28,000. That's during a backup period. But going forward, what we're going to do is we're going to size for these requirements. About 1,700 physical CPUs, 13 terabyte of memory or so, and a little over a petabyte of storage used. Okay, so now we showed you what we're going to tackle. Now we're going to show you how we're going to tackle it. So last week you were kind enough to give us time with your team. We walked them through how our software package PowerFlex works. PowerFlex is software-defined storage very simply. I like to call it next generation storage. It is all software defined. It utilizes existing x86 systems. In our case, what we deploy are PowerEdge servers, whether they be 13, 14, 15, soon to be 16G servers. But we use local DASD to present next generation storage and that next generation high speed, highly available, high-end storage. Now I should also note that this is high-end storage, but it can also be a hyperconverged solution. So hyperconvergence just means virtualization of every component. PowerFlex doesn't require virtualization at the compute layer, but we can utilize it if you choose to. Same with the network, for instance. But PowerFlex is always going to be software-defined storage. So we did move PowerFlex into the high-end storage bucket inside of Dell Technologies, and we've been able to take advantage of the engineering that comes with our high-end systems like PowerMax, for instance, so that we can bring data-rich features like replication and compression to the PowerFlex platform over the last few years. Now, PowerFlex is simply software-defined storage, as I mentioned. What would happen today if you had 24 servers on the left-hand side? Each one of those had 10 drives inside. Each one of those was 76.8 terabyte of storage. You would have a top end of performance that you could get out of each one of those systems. What PowerFlex does is it takes all of them, brings them together, and uses an aggregate performance of all of those systems tied together, which means any system attaching to the storage platform gains the advantage of all of those processors, all of that memory, all of those disks communicating across an Ethernet backbone. This is not Fiber Channel. This is not iSCSI. You might hear me talk about targets. You might hear me talk about virtual HBAs, but know that this is a proprietary protocol running across an Ethernet fabric. And if you take a look at the performance on the right-hand side, a little over a petabyte inside of that one cabinet, 5.5 million IOPS. The network is a very, very important component of a PowerFlex solution. That's why that Ethernet network has to be very well defined, and we deliver it often in one of our 2 consumption models. Within the confines of what we call a PowerFlex rack, we deliver a cabinet, or customer cabinet can be custom built into as well. We deliver access or aggregation or spine, leaf, or whatever management switches are required to guarantee the performance inside of that system. Everything is cabled up, everything is built, everything is white glove delivered in about 45 days with a PowerFlex rack solution. And again, in today's day and age, it's all based on availability of parts. Conversely, we have another product called PowerFlex Appliance, which is very similar to hyperconverged solutions you may see today, like VxRail, Nutanix, or others in the marketplace. We deliver the appliances, but the switches and all of the management can be bundled together, but it's a little more disaggregated in that regards. But we can bundle them together and still create a high-end PowerFlex solution utilizing all the advantages of PowerFlex software itself. And then on top of it, we have a product called PowerFlex Manager that we'll dive into later. But PowerFlex Manager handles the lifecycle management as well as deployment, upgrades, etc. on the entire platform, whether it be the rack system or the appliance. So we've thrown around some pretty big performant numbers. Let's talk about how we actually do that within the PowerFlex architecture. So PowerFlex is predicated on 3 applications, main applications. 2 of them we're going to talk about heavily today. One is the SDS in the upper left-hand corner. That's the storage data server. Storage data server is a little piece of software that gets loaded on a system that's going to provide storage to the platform. We start with a minimum of 4 SDSs, and that can scale up to 512 per PowerFlex cluster. Far, far greater than any hyperconverged solution in the marketplace today. Next to it, we have what's called an SDC. The SDC is a tiny little shim that creates virtual HBAs on any operating system you have in your data center, any x86 operating system. So Windows, Ubuntu, Fedora, KVM, vSphere, obviously, Hyper-V, you name it, we can deploy that SDC that can then talk across that Ethernet fabric to systems running the SDS. And if the SDS and SDC are running on the same system, we call that a hyperconverged system. That would be something like a vSphere host. Again, we'd start with a minimum of 4 of them, but those vSphere hosts would be consuming storage provided by themselves, running both of those applications. Now, this is the difference between a hyperconverged solution and a PowerFlex solution, in that we can have hyperconverged deployments, but we can also utilize bare metal. So those SDCs, again, can be running any operating system you see choose fit, talking to the storage provided by SDSs. And lastly, the real magic of the solution lies in the MDM, the metadata manager. We're not going to go down that rabbit hole today, but the metadata manager sits in a guard tower outside of the data path and monitors everything among the system. It handles all of the logical drive builds, layouts, the rebalance, rebuild operations. It's where the magic happens. And again, it sits outside the data path, but there are always more than 3 metadata managers inside of a system, so that's fully redundant. So expanding on this idea of hyperconvergence versus two-layer or disaggregated infrastructure, as we call it, in the middle you'll see there's 8 vSphere hosts. Again, they're running the SDC and SDS, consuming storage provided by themselves on those 8 nodes. The more common design that we've seen is this disaggregated or two-layer architecture, as you can see on the left-hand side. Compute nodes are sitting there running that tiny shim SDC that's talking to storage provided by those green nodes running our embedded operating system in the SDS. The nice thing about this two-layer architecture is that performing upgrades is very easy. If I want to perform a storage upgrade on those SDSs, I don't even have to do a vMotion off of a vSphere host running on those orange nodes. I don't have to, they don't know anything about the upgrades happening on the back end. Conversely, same thing for the storage nodes and the SDC nodes in the front end. Upgrades can happen, disruptions can happen. Also, if I have those SDSs at the bottom and I lose a drive or I lose a node for some reason, all of the systems participating in that what's called a protection domain provide compute and memory and resources and Ethernet fabric to help rebuild those components, whether it be a drive or a node itself. So all of the resources are dedicated to storage operations, as opposed to an HCI node in the middle where the compute, memory, and storage are all contributing to the same. If I have a problem on an HCI node, I'm going to pull away from my vSphere host, for instance, because I need to fix those storage operations as quickly as I can. And if I choose to add just compute, I can add just a compute node or 2 or 5 or 10 up to 2,000. If I want to add storage, I can add a storage node or 2 or 5 or however many. And that's what you see with a mixed architecture. Again, we generally lead with our two-layer architecture simply because of the ease of upgrades and the isolation of storage operations to storage nodes. So kind of touching on that idea of multiple operating systems, we have SDCs for almost everything you have in your data center. We even have drivers for AIX and the Power Platform. Now, obviously, this is quite a diverse solution that you see on the right-hand side. But if you wanted to test things, for instance, I want to test containers, or I love vSphere, but maybe I want to look at Hyper-V or OpenShift or OpenStack or any solution in the marketplace, we have those drivers available that allow you to utilize the storage underneath and the confines, again, of a PowerFlex solution, providing shared storage to everybody. And it's fast storage, so you never have to worry about performance not being there. And since we do have so many different options at that SDC layer, we have broad platform support for a lot of solutions, whether it be databases, analytics, cloud native apps, next-gen databases, AI/ML workloads. It doesn't matter. These can all run inside the confines of this PowerFlex solution, and we have white papers upon white papers and solutions that outline all of these capabilities throughout the ecosystem. And since we can be so flexible on the compute side, we can actually utilize your existing x86 servers that still have life left. In talking to your team, you have UCS servers that are going to be up for maintenance in June of 2024. So they still have almost 2 years. So we basically deploy the SDC. They get to talk to super new fast storage. They're never going to want to go back to Fibre Channel after that. So we touched on the components and the flexibility of the design. Now let's talk about how we actually get the speeds that we get today in a PowerFlex system and the availability and reliability, if you will. So 10, 12 years ago when hyperconvergence came to market, there were other software-defined storage solutions that came. If you remember back that long ago, 10, 12 years ago, spinning disks were cheap and very prevalent. All flash disks, SSDs were not. And so most designs required a caching tier that could be written to and then destaged to spinning disks on the back end, simply for cost reasons. There was no way that anybody could afford all SSDs or all flash back in that time. And so all of these technologies, including PowerFlex to some extent, had this caching tier in place. Well, what happened is today they still have that caching tier. So at the top, this is one of our competitors who requires something called data locality. They have to write to this caching tier. And then once data gets destaged, the performance is all predicated on how fast it can read and write to that caching tier, again, which is just a disk or 2 or 4 or whatever, limited number of disks. Another solution at the bottom has volumes that get written to, but those again are destaged from the caching tier. So all of the performance, again, is predicated on how fast it can read or write to that caching tier, and that technology hasn't changed in 10 to 12 years. Now with PowerFlex, what we did is we did have a caching tier in place called DAS cache, but we quickly got rid of that because we realized that spinning disks are going to fail. There's no getting around that. And so we pivoted to all flash and NVMe drives 5-6 years ago, and we've never looked back. There is no caching tier. When we write in big chunks of data. It gets written evenly across all of those SDSs providing storage, across all of the SSDs or NVMe drives that are there. And that performance is because of the parallelism that happens across that Ethernet backplane. So again, you can see how important that Ethernet platform is, and that it has to be clean. And that's why we like to deliver that Ethernet platform, at least in one of our solutions, that being PowerFlex Rack. So knowing that we have this massive parallelism, we can get numbers like this. So this is a 6.9 configuration. You're looking at drives, the mean time to repair of 136 seconds for a drive that's 50% full. That 4 terabyte drive will rebuild itself in 1 minute and 48 seconds, predicted. Completely unheard of. So do customers actually need millions of IOPS for their workloads? No, most likely not. Do they need them in the time of a rebuild or in time of operations or maintenance? Yes, absolutely. And that's where PowerFlex shines. So not only can we take on every workload in the data center, but we can also guarantee a high availability.
Oh my God.
So Dale, you nailed it, right? Very, very amazing numbers. And add to that the reliability, add in things like I mentioned asynchronous replication that's now built into the product. We have a new GUI. We had a Java-based GUI. We've now moved into an HTML5 GUI. We also have PowerFlex Manager that I mentioned earlier for the lifecycle management, deployment, everything. We'll dive into that a little bit later. We have data at rest options that are layered on top and also fully automated with PowerFlex Manager. We have secure snapshots. You want snapshots to stick around for 10 years? We can do that. You cannot delete them. Inline data reduction services, we utilize compression. Very, very good numbers there. We have something called protected maintenance mode. PMM, we like to call it, allows you to have a tertiary copy of data, so you're never in a degraded state, even in the time of maintenance or in the time that you've lost another node. And more, just features are coming very, very, very quickly. So lots of features, but let's talk about automation and lifecycle management. That's where we talk about PowerFlex Manager. This is an application that is delivered as a VM that sits inside of the 3 or 4 node management pod in a PowerFlex rack. It can sit on a 1 or 3 node for redundancy PowerEdge solution. But basically what it does is it goes out and discovers resources. Resources are nodes and software and vSphere clusters and PowerFlex components and switches. Discovers these components using what are called templates. Templates are basically recipes for combining all of these resources into something called a service. And a service would be something as simple as an SDS cluster of storage. It could be a compute cluster of ESX servers. But each one of these services then are what we run compliance reports against to see if they're up to date. And then once every 3, 4, 5 weeks, you'll get a big bundle with the appliance. We call it an intelligent catalog. With PowerFlex Rack, we call it an RCM. But it's a bundle of software, and that's firmware, drivers, everything, software, switches, servers, everything that has been tested, pre-tested to be completely compatible. So when you download it and deploy it to these services, whether it be compute or storage or PowerFlex components or whatever, you know that they're going to work because we've done all the testing already. And it really does make upgrading the environment very easy. No, it's not a one-click upgrade. It's about 4 clicks, but it's still very, very simple. And so stepping back and looking at it, this is what we use to deploy PowerFlex Manager. We deploy all of those services that you utilize. We handle all of the alerting. All of those alerts come into PowerFlex Manager and then talk to our secure gateway to open up tickets as needed. We monitor compliance. We maintain the entire system. If you need to do expansions, that's done through PowerFlex Manager, and upgrades as well. And oh, by the way, one of the checkboxes that you asked us to investigate was, how do we work smarter? How do upgrades get easier? Well, guess what? PowerFlex Manager, layered on top of PowerFlex Rack or PowerFlex Appliance, now makes those upgrades significantly easier, and we can check that box. So now I'm excited to show you what I think is going to be your next generation data center. So utilizing all of the tools that we have in place, the tech atlas that the teams put together, we have a solution that I think is going to be pretty earth-shattering, to be honest with you. What we want to start with, and this is just an option, we can always boil the ocean, but it's always good to tackle the most dependent workload, if you will, or the most troublesome. And what we see in your data center is that Nutanix cluster. Again, running very, very hot. It's not performing. You can't expand it. We hear that a lot with Nutanix clusters. So our solution would be to, hey, let's take and split out your compute and storage on the Nutanix cluster, and let's build out an initial PowerFlex rack solution. So if you'll notice at the top, we have our out-of-band management switch. We have a pair of access switches, a pair of aggregation switches, which will allow you to scale this cabinet out to about 14 cabinets, maybe. Your management pod, we have 3 of those. We can scale that out as needed. If you want to run NSX or other applications inside of there, you can. That's where PowerFlex Manager will run. And then down at the bottom, we're going to start with a minimum of 4 SDS nodes. That's providing storage, about 100 terabyte, probably just a little over 800,000 IOPS on those 4 nodes. Definitely more performance than you need, but again, this is for future proofing. And then 3 compute nodes sitting above that would provide all the compute that's required for that Nutanix cluster. Now, big picture, you could grow into, or you could start with the full solution, and that's what this would look like. So this includes that Nutanix solution as well. You'll notice all the switching in place for these 3 cabinets. We're providing about a petabyte of storage, a little more than that with all of the yellow nodes. That's across 2 protection domains and 2 cabinets. We have 28 compute nodes that will take on all of the 1700 physical CPUs that you require on the right-hand side. And OLUK, your Oracle, we isolated it into these 4 nodes. So all of your Oracle systems you have today, we've talked to your DBAs. We understand the licensing you have in place from a core and socket count. And we've been able to map it exactly using the processors that are there. That should save you probably a couple $1 million a year just in Oracle licensing alone by isolating to these compute nodes, accessing the storage provided by PowerFlex on the back end. And since we're knocking off checkboxes, let's get another one too. Now from a performance standpoint, every workload can run inside of PowerFlex, and you'll know that it's going to work far better than anything that you have in place today. Look at those numbers, 6 nines of availability. That's 3 minutes of downtime per year. 7 million IOPS, 54 gig of throughput. Every application is going to run much better, and it's all been standardized on one platform. That's PowerFlex. And going back to that idea of existing assets, no problem. What our team will do when we deploy the PowerFlex solution, whether it be the small or the big build, we'll actually deploy those SDCs to your UCS blades so that you can now access the PowerFlex storage across the data center and take the advantages of the speeds that you're going to get from that PowerFlex solution. A lot of our customers, when they deploy a simple workload with PowerFlex inside their data center and don't take on the entire data center, we have something called PowerFlex Envy, where everybody wishes that they had it in place, and they very quickly move workloads over to PowerFlex. Now, one other thing I didn't mention is the savings in your data center. By consolidating everything that you have in the 8 cabinets you have today down to 3 cabinets, plus maybe an extra, you have a tremendous amount of space now inside of your data center. And in a colo facility, that's going to be very important. That'll save you a lot of money.
So much extra space in our room to do activities.
That's right, Brendan. You will have a lot of extra room, that's for sure. Now, when we talk about delivering this PowerFlex rack solution, I want to just walk through some of the details that are going to be provided. So we talked about the switching that's there. This is all going to be, again, pre-cabled, pre-built, pre-engineered, using all of the input that we get from you, using a logical configuration survey and a site survey. We're going to build this in factory, and we're going to bring it out pristinely, white glove service to your data center, again, very quickly and in short order. Then once the factory gets a hold of it, then we'll be able to pump out things like a cabling diagram. You'll know exactly the number of cables out of each node, where they're going to plug in. We'll have port maps. You'll be able to see the network diagram, the Visios that are there. We'll also have the environmentals in place. You can see the wattage, the BTUs that are required. We even have the weight of these cabinets. They're not light for your environment, so that we make sure that it does fit into your environment as well. Power options are off the charts. Whatever you can provide, we'll make recommendations, but we'll cater to what you have in your facility or your colo facility in that regards as well. So when this production system is deployed, you'll basically go from the 16 element managers that we identified today with the existing infrastructure. We're taking that down to 3 element managers. That's utilizing vSphere, PowerFlex Presentation Server, and PowerFlex Manager to run your entire environment. Making it much simpler. Obviously, that was one of the checkpoints too. Let's make this much simpler. Think of how many folks this would take to now administer it, as opposed to all of those 8 FTEs that you have administering your existing system. Some of those folks now could be converted into architects. They could be talking about cloud implementations. They could be business analysts. They could be getting requirements from the business and bringing it back, and you can actually start working more proactively again. And it's all based on the fact that you've shrunk your service catalog and you've brought in a solution that makes operations and your life much, much, much easier. All right, now I promised you something around disaster recovery. So let's dive into that real quick and show you what we proposed. So Dell Technologies has been working with hyperscalers for a number of years. AWS, we're bringing to market a product called Project Alpine. That's coming this summer. Basically, all of the advantages that you expect out of the hyperscalers, the ability to power up your workloads to expand, that a consistent experience, the ability to pay by the drip, pay what you use, all of these features that you expect out of the cloud, we can now utilize. And what we're simply doing is taking Dell's intellectual property like PowerFlex and making hyperscalers like Amazon better. So utilizing native PowerFlex features like async replication, we're able to take edge or on-prem systems and actually create copies within Amazon based on regions that are closest to you or maybe not. But we're utilizing that PowerFlex technology to also build out PowerFlex solutions inside of AWS to start. And again, this will come with Google and Azure in the future. But it's being able to say, hey, guess what? I've done my cloud diligence. I know that my storage can run out there, and then I just layer compute on top of it. And it looks a lot like this. So EC2 instances are what are utilized to deploy that SDS and MDM. Sitting underneath them, we have one of two storage devices. We either use Amazon's EBS volumes that are persistent, or we can use local NVMe, which are less than persistent per se, but much, much, much more performant. And then utilizing one of these two solutions, we can provide that storage, which we then simply layer on top EC2 instances running vSphere that can provide your workload. So in this case, we would basically take your existing infrastructure. We would then set up that async replication to AWS. In your case, you're out west, so maybe region AWS West 1 would be the first deployment, and then we could replicate that data somewhere else as needed. And in talking to your team, it sounds like only 50% of your assets really need to be backed up or running in the cloud in the case of a DR situation. And so we sized for that. So as you'll notice, we know the exact size of the VMs, those EC2 instances. We will require the M516 large, extra large, excuse me. For the PowerFlex SDS controllers, we'll have the C599X large. We'll have 10 of those running on the back end. And this solution itself will provide about 50% of what's available on-prem, but that 50% is the data that is required to be protected. And so guess what? You've killed two birds with one stone. You now have a DR plan utilizing PowerFlex and the technology of being able to replicate to the cloud. And you have a plan for the cloud now. You have an ingress point that you can now build on if you'd like. You can start building applications specifically for the cloud if you want, but you've done that cloud due diligence, and that's something that most companies haven't done. So hopefully the solution is something that piques your interest. We're very excited about it. We think it's a great fit for your environment based on the input that we received from your team. Now it simply comes down to a consumption model. We have a few options. Obviously CapEx is always an option. We also have a lot of pay by the drip options, and Apex and Flex on Demand are options that I think we would at least like to have our sales team talk to you about. So again, it's one of those cases where we have a utility model where you pay for what you use. You can put a certain amount on the floor and pay for it as you grow. That's always another option. But at the end of the day, one of the check boxes, again, that your team came to us with is they don't want to do forklift upgrades anymore. They're tired of having a project cost millions of dollars because they need storage and maybe a little bit of compute. With PowerFlex, again, we can add compute or storage or both. We can expand very quickly, very easily. The engineers know exactly how far it will scale and the path to get you there. And with Apex and Flex on Demand specifically, you can now pay as you need with the infrastructure already in place. So hopefully the solution has made sense. At the end of the day, and as a roll-up, we've taken the issues that your team has brought to us. Things like we have too many element managers, we're not working efficient enough, we don't have a DR solution, we haven't investigated the cloud, et cetera, et cetera, et cetera. And we've knocked them out. It's all based on PowerFlex software. It's all based on PowerFlex Manager. It's all based on limiting the complexity of your data center and working smarter and not necessarily harder. So hopefully this all makes sense. I'm going to open it up right now. Do you guys have any questions for me?
So good. Yeah, I really would like some.
So fair enough. Thanks, guys. Appreciate your time today. Any product updates, if you're a Twitter fan, please go out to @PowerFlexMan. There'll be updates there periodically. As far as the next steps go, what I'd like to do is I'm going to get you hooked up with our sales team, have them walk through those consumption options, see if there's any tweaking to the configs that you want, talk about reverse timelines, and try to get something in place. I really believe that this is a solution that will help you guys. I think you kind of see that advantage as well, and we're really looking forward to helping you grow your business. Thanks for the time.